One thing maybe that we would emphasize if we would rewrite this paper at this point is the importance of humans as the next frontier of artificial intelligence. I mean, humans have been quite underrated and underappreciated, especially initially in the initial development of these large foundation models. And the study of humans in relation to AI and, how humans respond in relation to AI, I feel is of core importance for what is called AI alignment. That's essentially aligning artificial intelligence to human responses, making AI a bit more human-centric.
Welcome to ODSC's Ai X Podcast, your gateway to the latest in AI and data science. Whether you're an aspiring data scientist or a seasoned AI professional, we bring you insights from the best minds in the field, shaping the future of AI. This episode is sponsored by ODSC West, the premier AI Builders Conference celebrating its 10th year this October 28th to 30th in San Francisco and virtually. Learn more at odsc.com/California and use the code PODCAST for an exclusive 10% discount. Hello, and welcome to the next episode of the ODSC Ai X Podcast. My name is Alex Landa, and I'm the head of content here at ODSC. Today, we're speaking with Georgios Yannakakis, professor of the Institute of Digital Games at the University of Malta, co-founder of Modl.ai, and editor-in-chief of the IEEE Transaction on Games. So thank you very much for joining us today. First of all, tell me a bit more about yourself and your background beyond what I already mentioned.
Right. So, I'm an AI professor and researcher that loves games, essentially. And my work is all about bringing the power of AI forward to improve how games are designed or developed. And I've spent about 20 years of my life doing this, building AI models, understanding how players react when they play games, building AI tools that assist the design process. And beyond player modeling and procedural content generation, which are my core areas of interest, I have been also studying a bit the use of AI for game playing agents, for testing games, and so on. So as you said, I'm based in Malta at the Institute of Digital Games, co-founded two companies. Modl.ai focuses on the uses of AI for automatically testing video games. And Human Feedback AI focuses on providing a platform, tools, and services for AI engineers to collect data so that they can build the next generation of AI. I'm the Editor-in-Chief of IEEE Transactions for Games, which is like the premier the journal on technical games research. I have been the author of the first textbook on artificial intelligence in games, which one can find under gameaibook.org. And I have been the organizer of the AI in Games Summer School with Georgios for the last 70 years. During this summer school, we have been training more than 1,000 professionals from the video game industry, PhD students, doctoral students, and researchers on the basic principles and use of AI in video games.
That is all very cool stuff. And I know when I spoke to your colleague, Julian, a few weeks ago, he told me a lot about that summer school that you do, Modl, of course, the book, which I did read a bit of, all very cool stuff. So I definitely want to hear your take on some of that stuff. But a few weeks ago, you sent me a paper that you published about a year ago. Choose Your Weapon, Survival Strategies for Depressed AI Academics. I love that title. Very relatable stuff. And it must be wild to be an academic now in the age of AI. So I will, of course, link to this paper so people can read it. But what are your high-level thoughts about that?
Yeah, the particular paper has quite flamboyant title, but it's not as depressive as it sounds. It's actually very positive. It has a very positive tone at the end of the day. So Julia and I work together a number of years now, more than 15 years, and we have co-authored more than 100 papers or more, 200, I don't even remember, and a book. This paper, Choose Your Weapons, was a paper that came through a very internal process, quite extensive brainstorming meetings we had with Julian and other colleagues throughout the conferences, academic conferences we are visiting. Now, the paper takes quite an honest approach, I would say, and at sometimes a satirical look at the current struggles of academics We just wanted to talk essentially about the current struggles of being an academic in the AI space these days. And we put together, I believe it was 13 different strategies on how to remain relevant and how to do high impact research in 2023. This current era is dominated by scale, essentially. Big data, big models, big money, what you need to put into the models so that you train with lots of data. And it was, in a sense, it was a way of saying you're not really alone on this. Now, I might read from the paper, there's one core observation and the core driver for us to motivation to write this paper, which goes as follows. As recently as 10 years ago, if you had a decent computer and an internet connection, you had everything you needed to compete with the best researchers out there. Well, guess what? It's not the case anymore, right? Despite the flamboyant title, the paper ended with a very positive note. It was very well received. Both of us with Julian were invited to give talks across the globe, including, let's say, the Allen Institute, the Alan Turing Institute in London.
You mentioned you did this in 2023 and it was published last year. Like AI has been just moving way too fast. Since it's already a year old, what would be different if you wrote it today?
Well, you know what they say, 1 year in AI years is like a lot of time, given the pace of how AI moves today. We thought about this. We discussed the matter with Julian. How would it be if we rewrite this paper again today? I don't think many things would change. The core message would still remain the same, I think. The context maybe would have been a bit more urgent, given the current pace and its acceleration since then. And the very fact that what is called scaling maximalism, which essentially means, the higher the scale, the more the money, the more the higher the amount of data, the larger the models, then the better the model ends up being. This is what scaling maximalism sort of implies. But, this thing is still ongoing. And then Sutton, one of the founders of reinforcement learning, talks about his what he calls his bitter pill. And he refers to the insight that simple methods that scale will always win the day when more compute is available. So, but of course, then one might think as a counter argument that resources are only limited and the scaling bubble at some point will burst, and the AI bubble will burst at some point. All this hype. So we feel that the need of smaller models is still relevant and will become even more relevant for AI applications more or less everywhere, especially your mobile phones and even your desktop. And it's going to be useful for both research and industrial applications. Now, one thing maybe that we would emphasize if we would rewrite this paper at this point is the importance of humans as the next frontier of artificial intelligence. I mean, humans have been quite underrated and underappreciated, especially initially in the initial development of these large foundational models. And the study of humans in relation to AI and, how humans respond in relation to AI, I feel is of core importance for what is called AI alignment. Basically, essentially aligning artificial intelligence to human responses, making AI a bit more human-centric, developing AI that acts in a more emotional, cognitive, behavioral manner that feels more natural to us than it is today. But we need humans more than ever because we need to also develop safer, more explainable, more trustworthy AI, right? And humans are the only way to get there.
So in your paper, you specifically dropped a few companies like OpenAI, Google's DeepMind, et cetera. So a lot of these changes in AI can be good, but also can be very stressful. So when you do academic research, have you had to alter your strategy preemptively, expecting change from these companies?
Researchers had to adapt to a degree, especially academic researchers living within university labs. Now, believe it or not, I don't really like the idea that language, for instance, is the dominant modality that drives the AI world nowadays. So I had to adapt my research using such models that rely on language in creative ways. And we describe a few of these strategies in the paper, actually. So one of the strategies was to care less about predictions of where AI is going to land and what's going to happen next, but care more about building some sort of healthy environment within my lab, sustainable environment, an academic lab that is robust and can work on core research topics independently, to a degree possible, independently of what OpenAI will be doing. Right? So we develop methods, let's say, that very few people care about. See our paper for more information. This is one of my favorite strategies, and I've been following this strategy throughout my career. Usually the problems I initially tackle, very few people care about, and some of them become a trend, and that's beautiful. These solutions can be agnostic to large language models. So instead of building something that works only with large language models, we focus on the underlying principles. We're trying to analyze them. We're trying to break them. We're trying to look at their architectures. We're trying to find novel uses within human-computer interaction, and video games is what we do as a domain. Or perhaps combine computer vision with language models and languages, trying to build multimodal models. And there's so many different uses actually out there that they are not large language models. There's so many things that are AI that is not about language or large models. So we are trying to improve AI methods with my students in novel ways. For instance, traditionally we have been playing quite a lot with neural networks and evolutionary computation, and we stick to that plan. We still combine evolutionary computation methods, open-ended evolution, on their own or in conjunction with large models, or even combining computer vision with large models. So there's quite a lot of diverse ways of surviving and still have impact globally by either analyzing and breaking those huge models or working on the sides of this sort of dominant research stream, let's say. This is what I've been doing.
It sounds like a better, healthier approach to set up a solid foundation and environment where you're not totally dependent on the powerhouses to change everything. Worry about that when the time comes. You can have control over your own lab and environment.
Right.
So earlier you talked about something that I do want to go back to that was really interesting. The underrated value of human data in AI and human in the loop. So could you maybe tell me a bit more about that, and then eventually how that relates to gaming in particular?
Yeah. So if you think about today's models, the very best language models or video language models, they struggle with predicting our own emotions, our preferences, our intent, because they are trained upon and they rely on static text language data and ignore really how people feel and respond at large. I mean, some of them do a very good job, don't get me wrong, but there's like a huge gap between what they can do and what we want them to do when it comes to this alignment that we're talking about. Another thing we need to remember is that AI is not really only about large models, and certainly not only about language. So if we want AI to actually reach that human level performance, we have to learn from something that has more rich context, higher bandwidth, like videos. And guess what? We don't really have a lot of labeled videos with subjective notions such as artistic values, ambition, trust levels, stress, happiness of people. So most of the content we see online and is used to train those large models is built on very objectively defined notions such as, where's the car? Where's the traffic light? Where's the bridge? You might have seen those while you're searching on Google, or you know exactly what I'm talking about, right? So human labor for free, where we are asked once in a while to actually detect things over images. So what we offer here, and this is the aim of this new venture we call Human Feedback AI, is we aim to unlock the more or less what we feel is the final frontier for artificial intelligence, which is truly understanding humans. And to train those human-centered machines of the future, we will need a lot of appropriate human-labeled data that we don't really have today. So the vision is to offer tools that will enable AI engineers to realize this vision by delivering fast, reliable, and time-based human feedback on videos. Now, you might wonder, where is that applicable? Well, to any industry that operates on videos. And, video game industry is full of videos of gameplay, of how people play, how they behave, how they feel while playing games. So the application to video game development is clear. We will know at any point, if we could have this labeled data, we would know at any point how emotions are colored or experiences are colored or manifested throughout a gameplay. And then we might use procedural content generation methods or generative AI methods to adapt and personalize games to a player's own desired experiences.
Since we are both big fans of gaming, and I do want to continue on this thought pattern, how have you adjusted gaming research to compensate for this quick growth in AI?
So over the last decade or so, we have seen the AI growth and the development has changed the way we approach games rapidly. And if you think about it, and perhaps other researchers touched upon this, AI and games are so heavily interconnected. They're like, it's a wonderful couple. It's a great marriage that lasts for the last 70 years. So we initially started with methods, AI methods and algorithms that want to beat every human out there, and like superhuman AI that plays better than any one of us, chess game or a Go game.
Yep.
Then we dedicated a lot of research and money, time, resources to actually make that happen. Somehow we feel that if an AI player plays better than any of us a particular game, this manifests some sort of intelligent behavior. You might want to argue against this. It's more of a philosophical debate. I don't necessarily agree. I don't think that playing chess makes you smart. But it gives you, it's an interesting skill that cognitively, planning-wise, that if we manage to replicate or play better than a human, then it might tell us something about artificial intelligence. And maybe also tell us something about human intelligence, the different ways we follow sequences, we take decisions and so on. But, this is what happened predominantly for the many initial years of AI and games. And if you visit any Wikipedia page nowadays about artificial intelligence, you will soon realize that the vast majority of AI milestones are associated with games. So think of the Deep Blue moment where Gary Kasparov lost by Deep Blue, IBM's Deep Blue back in the 90s, all the way to AlphaStar, DeepMind's AlphaStar. And the number of algorithms that have been invented through games like research, variance, Monte Carlo research, deep reinforcement learning, multi-agent reinforcement learning, and so on. The list is endless. Now, that's great, but honestly, there's so much better and diverse use of artificial intelligence in games. And I can list like a few. We touched upon procedural generation, and there's so many different ways you can actually do that. You can procedurally generate visuals, audio, music, narratives, levels, entire games. And you can do that through simple evolutionary algorithms. What was back in the day, trendy when I was doing my PhD 20 years ago. Nowadays, you can do that with large language models or video language models. You can test games using AI. You can do that with reinforcement learning agents, but you can move on into nowadays methods and, try out vision language models as we do at Modl.ai, right? You can do research on explainable and ethical AI for game design and development. You can have player adaptive games that recognize emotional patterns or behavioral patterns, and then they adapt content to your liking, or they adapt non-player character behaviors so that they create a personalized experience for your personalized narrative in a particular game. So many of these uses are described in the book that we all co-authored with Julian. It's like 550 pages of many, many different use cases of AI in games. So it's not just playing games better than any other human. I believe we offer more than 1,000 references. So if people are interested, they can go in there and actually there's a free version at gameaibook.org. You can find a free version of the book, early drafts, free to download.
Is the original version that you just said for free, how different is that from the full version?
Slightly different. It's like, let's say a few months apart. Like it's an early draft. So, yeah, if you like the early draft, you can go ahead and buy the book.
Cool. I will probably just end up getting the book. Love reading about this research. I would love to hear some specific examples, if you have any that you can share, or maybe some studies that you've personally been a part of or ones that have inspired you. just kind of interested in some of these game studies that maybe are a bit niche or smaller in scope.
Right. So as I said, the most significant shift over the years when it comes to AI in games research has been from the complete focus on superhuman AI to a diverse set of studies and interests across the board, various use of AI in games. And I mentioned a few earlier. But I think I can mention a couple of examples from my lab at the Institute of Digital Games.
Yeah.
And I would say that, one area that I particularly like and my students like is building models that can adapt to a player's emotional state and skill level. So a recent example is as follows. We just published something on racing games. There's a number of industry players out there that focus on making the very best possible racing game agent that plays a game like Gran Turismo in the best possible ways. One example of this is Sony's Sophie AI agent that plays Gran Turismo better than any other human. Now, an alternative approach would be to not do that and to create an AI that understands you when the player is getting frustrated or bored, and then intentionally make a mistake when it designs maybe a level, or change its racing style to be more aggressive or defensive, or even create some shortcuts, adapt the level accordingly as an AI designer to your own liking. So this type of research, it's known as player experience modeling or experience-driven generative AI, where generative AI or procedural generation considers experience patterns of the players so that it offers personalized experience to them. Now, another area that we work pretty hard and quite a lot at the Institute of Digital Games is procedural generation, right? So you have what is called nowadays generative AI in games because it's a sexier term. But the focus there has moved, especially with these large language models, to what is called mixed initiative procedural content generation. So why mixed initiative? Because you have an initiative from a human that goes in and has an intent, a desired intent. I want to design, let's say, a level in Super Mario, for instance. And then you have an initiative that comes from the machine, from the AI. And these initiatives are mixed in an iterative fashion, eventually leading to a creative dialogue between you and the AI, and finally delivering a level, a game, some new visuals for your game, and so on. Now, this is the best use of one of the better uses of artificial intelligence in games, especially in this generative AI era, where there's a lot of critique of artist rights and fear about jobs, including academic jobs on artificial intelligence. I mean, we wrote a paper about it, but there's a lot of fear about what's going to happen. And I think the two arguments against that fear is that, first of all, AI should be used in collaboration to a human in a co-creative fashion, where both create in different ways and they help each other to make a new game. Because alternatively, I cannot really think of AI that designs games autonomously, fully autonomously. Like, it takes its own initiative and designs an entirely new game. Now, I might ask you, Alex, what kind of game would that be? Would humans actually want to play this game? Does it make sense? Does it have any artistic, creative value? All these are philosophical questions. But I think I'm going back to my original position here. I think when it comes to generative AI, the very best use, and probably the only use that we should be looking at, is where an AI is taking the role of an assistant in a creative design process.
You brought up something in relation to the Gran Turismo example, sentiment in human emotion and how it adapts to that. So what is used to measure emotion? Is it based on the in-game variables? Like, do you set it up so that the game AI can tell that the person's getting frustrated or maybe losing too badly? Or is this like an external thing of like using a camera to measure?
Right. There are many ways to do that. And one of my favorite ways is to initially try out and build a model through supervised learning. Now, normally you have human demonstrations, you have data that come from humans on the behavioral space. So you basically have, in the case of a racing game, you have the line, the trace, right? While the player is playing. So you have that. And then when you're trying to build a model that plays like Alex, then you try to imitate this line. Now imagine if you have human demonstrations on the emotional space, like, the stress level of a player or the engagement level of a player. This is also a line, if you can picture it, right? So returning back to what we do at Human Feedback. So if you can provide those human demonstrations, if you can actually ask players to play the racing game and then watch how they play and leave a number of emotional traces, like the intensity of their emotion, then you can train AI agents that play like and feel like humans, or Alex was so on. Why is that important? Well, for many different reasons. First, because you can create different personas that play and feel like Alex, Georgios, whoever the player is, and automatically test games with different sort of emotional behavioral patterns of players. You can take it one step further and inform generative AI algorithms that will consider those behavioral and emotional models to generate new levels for Alex, right? They maximize the intensity of emotion for Alex or make the game as boring as possible, whatever the designer wants. This is possible nowadays. And it's possible using a different number of algorithms. What we did recently in our lab was to utilize reinforcement learning as a design process. Normally, reinforcement learning is viewed as a process where you have an environment, you have an agent, the agent gets a reward from the environment, it gets informed about the state of the environment, and then it takes an action. Usually, reinforcement learning is applied in robotic tasks or sequential decision-making tasks. Now, what if reinforcement learning could be applied to design? The action of the agent is not a behavioral action, but a design action, like, changing a tile in Super Mario, in a Super Mario level, or changing the next segment in a Super Mario level, if you see what I mean. So there are so many different ways of actually doing this. Initially, I think, you get back to your question, you would need some labels from humans, some demonstrations on the affective state, emotional state, and also the behavioral state. Let's call it behavioral state and affective state. So I think there's a lot to be done on player adaptive games that we haven't done yet. And there are many reasons for that, because there's a degree of unpredictability. So game companies are a bit scared of drastic changes in their game content during the interaction. There is most of the problem in many games has been solved with these sort of very fine-grained, not really fine-grained, quite the opposite, actually. These non-fine-grained sort of skill types like easy, hard, medium, and so on. But I think designers always have a player in mind or a set of players in mind when they design games. And these kind of techniques can be very useful during the design process because they can offer different ways of testing your games, like different human personas or AI personas that can test your games. They can visualize what's going on. So they're very useful for the user experience analysis. Imagine that, for instance, an AI agent that drives around like you and colors their own sort of emotional intensity or engagement while they're driving. So this is a really useful design tool. We see that in a number of games, in a growing number of games. I think the future of video game development will rely more and more on adapting processes that adapt to the user preferences, the player preferences across particular games, across genres of games, or even across game genres. Alex has a particular profile. Google Play knows a lot about this profile. Many people know about this. Your data is out there. Do we agree this is utilized for offering better player experience? It is definitely utilized for you to buy more content. But in the ideal world, and this is what we're aiming at, we want to see the next generation of games where personalization makes a lot of sense. It is there, it's operational, but it's also meaningful because often people preach about personalization, I need my own game the way I like it. But over-personalization might also lead to bubbles where Alex plays a very, very particular game that he likes, but there's not much room for exploration of new experiences. So, it needs some care. This sort of dynamic balancing of Alex's experiences needs some care.
So I'm going to take a break for a question, and I need to ask you, what is your favorite game, or at least genre of game?
Wow, there's so many. Very hard to actually just list one. So I can just tell you which games I played recently.
That works.
Hades was one of it destroyed my Christmas holidays. I was so immersed in this game. And it's culturally relevant because, I'm Greek, so I can relate to the story, but I love the character design, the underlying content generation algorithm, level generation algorithm. It's a dungeon crawler. It's beautiful, very, very well designed game. Assassin's Creed series, some of them I like quite a lot. Minecraft, obviously. It's like many games. Tetris is a favorite game of mine. I just like good games whenever I see them. And there are many out there.
Yeah, definitely.
Yeah.
Okay. I love JRPGs, so I tend to mostly play those, but I will branch off into action RPGs. I love Tetris. I will always claim that Tetris is the one game I'm actually good at. Just because I love games doesn't mean I'm very good at them. I am not coordinated, which is why JRPGs tend to work pretty well.
So guess what? I mean, Pac-Man is one of these games that was really popular when I was young, so back in the 80s. And, that's the reason why my research on AI games started from Pac-Man and this kind of games, and then moved on Super Mario Bros. So, these are the games of my generation. And it's very normal that you get attached to these games. And if you do research, you end up doing research with the games you loved as a child. So yeah, my first academic paper was on modeling player interest in Pac-Man, right? And adapting the ghost behavior so that the interest level for the player is maximized. So it was one of the first papers that didn't want to optimize the performance of an AI agent, but they wanted to optimize the fun level or the interest level of player. And that was like, 20 years ago or something.
Oh, that's super cool. The ghost behavior, maybe the number of items, or those kind of things that would be adjusted.
Exactly, yeah. And the ghosts were controlled by a very small neural network. And that network was evolved over time to maximize its fitness. And the fitness was the interest level of the player. Now, you might ask, how did you measure interest level? Well, it's a long story. Long story short, went around and actually found an MIT professor called Thomas Malone, a psychology professor, that developed a number of criteria for Pac-Man-like games and this kind of early arcade games that he would claim are universal when it comes to player entertainment. And, I went and modified and quantified those criteria, those theoretical factors into a formula, and then I let it run, optimize, asking Ghost to basically maximize this sort of interest value. That was fun.
So, second to last question for you. Tell me more about the approach of try things that shouldn't work that came up in that paper.
Yeah, this is one of the strategies we described in the paper, one of the 30 strategies, and it's one of my favorite ones. So it's about embracing risk in many ways. If you think about it, Alex, the beauty of academia is that the failure matters, and it can be as instructive and valuable as much as success, right? If you think about it, stakes in academia are much lower compared to industry. So we as researchers often are trained to be very rational and logical. But if you follow this path, a very rational step-by-step process in research, what like is going to lead to incremental research with predictable results that no one would care about. So one really needs to be disruptive here. This strategy, try things that shouldn't work, is essentially provocation to people. We're giving permission to people to do crazy stuff that seemingly will never work. But sometimes this crazy stuff actually works and you make an impact. So you need to think of a hypothesis that is almost certainly false and build an experiment and test it anyway, right? So it's like something really, really weird. Why you want to do that? Because, if you fail, even weird results can come out of this. This might actually prove more insight than anything else, than any incremental research you've been doing. So what we describe in the paper, and I think it's very important to note here, is that most progress in artificial neural networks, in deep learning, even in transformers, which is the state-of-the-art architecture that sits under the hood of ChatGPT and the large models, comes from a bunch of few researchers, initially at least, that were stubbornly working on neural networks, back in the days and in the era where neural networks were out of fashion, no one wanted to work with neural networks because there were good theoretical reasons that they will never work. 20 years ago, the hot topic was support vector machines, even big offers like, new rips and so on. No one really wanted to work on neural networks. Even nowadays, after all this massive revolution of neural networks, very few people understand, I think, why and how the transformer architecture actually works, but it does. So it's like a very weird idea that someone put into a paper. The attention is all you need paper, which is a great collaboration between industry and academia. Actually, you will find nowadays that most great AI papers are coming from such collaborations.
Mm.
And, if you want, I can think of another weird example from our lab, something that we call affective mirror. Usually, in order to understand humans and their emotions, as we discussed earlier, you need to observe humans, right? How they behave, how their facial expression looks like, how they manifest emotion through physiological signals and so on. We said, forget about all that. We don't want to observe humans because there are privacy concerns, and we don't really want to do that. What if, in games, for instance, all you need is the pixels video game footage? What if we could actually look at your screen and infer how much entertained you are at this point? That was a crazy idea, but it turns out that it's valid. It's actually true. We can actually do that across a number of very simple games, but still we can do that with very high degrees of accuracy. We can look at how you play, just your screen, without looking at you, and predict, for instance, the intensity of your current emotions.
Oh, that's super fun. Like, maybe if you're playing more offensive than usual, or the complete opposite, maybe you're just kind of like an MMO. You're just adventuring, you're playing more relaxed, possibly.
Right. So I think there's the underlying hypothesis here was that we look at your screen, we look at how you play, and we ask a neural network to predict, just by looking at the pixels of the screen, to predict your emotional state. Now, what we found out from our studies is that in order for a neural network to do that, it needs to observe how you play, but also needs to make connections, somehow triangulate information between how you play and your score, maybe your health bar, other elements of the UI. So, player experience is a holistic thing. And then a neural network, while looking at your pixels, can actually find a lot of information. And maybe that information is all it needs in order to understand your player emotion. It doesn't really need to see your face or access your smartwatch, right? With your signals. We don't necessarily need that. So that was the beauty. That was the innovation of this sort of crazy idea. It turns out it works.
Oh, that sounds very cool. Is that paper out?
Yeah, that paper actually, parts of this work was also awarded by IEEE Transactions on Affective Computing. The paper is called Pixels of Emotion, maybe?
One pixel's all I need.
That is Pixels of Emotion. Yeah, the pixels and sound of emotion. General purpose representations of arousal in games.
And for my last question, how can people best follow your work?
Right. As I said earlier, a lot of my current work focuses on affective computing, user modeling, and procedural content generation in games, and how the two can be combined to come up with entirely new experiences for designers and players of games. So I'm particularly interested in how we can use, let's say, procedural content generation, generative AI, to create interactive systems that can become assistants and partners during a creative process. So think about AI that can co-create a game or help a musician or audio designer to compose a new piece, a new sound effect maybe, by providing surprising novel types of suggestions, content. And I'm also very much interested in ways we can model users of AI-enabled systems like games. Most of them have AI these days. And then by doing that, I'm interested in the ways we can detect their behavioral and emotional patterns of both players and designers, I would say, because designers are also humans and they leave traces while they design. And that's a very fascinating area of research. So I mentioned the Behave framework earlier that got the best NVIDIA paper award. And another example of very recent work of ours comes from my PhD student, Cosmas Pinitas. He introduced a player experience modeling framework that can train itself in many user modalities that you have available in a game lab. Think of biosensors again, think of cameras that track your sort of facial expressions that you don't really have available when you play a game in your living room. Now, the question is, to which degree these player models can actually operate very well in the wild while you're playing in your living room, now that you don't really have access to all these exotic sensors anymore. It turns out that he used a combination of contrastive learning and knowledge distillation. These are terms and areas of AI research that are quite active these days. But the combination of contrastive learning and knowledge distillation led us to that breakthrough. And that paper got an outstanding paper award at the IEEE Transactions on Games. Transactions on Hector Computing. Confused it with my journal. The award was given a few weeks ago. And, Transaction Affect Computing is a very high impact, leading journal in this field. So, but, as for following my work, the best place I would say is my university profile, the Institute of Games, University of Malta, and my Google Scholar page if you're interested in my research. If you're interested in the things I do beyond my research, like innovation within the companies I've co-founded, then feel free to visit the web pages of Modl.ai and humanfeedback.ai. And of course, my social media. I'm quite active on LinkedIn these days. Now, my personal website, it's my surname.net, Yannakakis.net. It's there, but it needs some serious update, I can tell you. So it's on my long to-do list at some point. So yeah, it has been a pleasure.
Great. Thank you so much. I will link to everything that we've talked about. I definitely want to check out some of these papers myself and give them a read. And yeah, again, thank you so much. This has been a wonderful conversation.
Thank you. Thank you for hosting me.
Your engagement directly contributes to the growth and success of our community. Please subscribe now and don't miss out on the next enlightening episode. This episode is sponsored by ODSC West, the premier AI Builders Conference celebrating its 10th year this October 28th to 30th in San Francisco and virtually. Learn more at odsc.com/California and use the code PODCAST for an exclusive 10% discount. Supporting our podcast by subscribing not only helps our small dedicated team at ODSC, but also unlocks exclusive benefits for you.